Welcome to ScienceCover.com. In this session, we'll look at radioactive decay. We'll learn how to write the decay equation for alpha emitting sources and the decay equation for beta emitting sources. And then we'll look at the dangers of different types of radiation. Pause the video and try the Do Now task. Let's check the answers. Question 1. What is an alpha particle made from? It's 2 protons and 2 neutrons, or a helium nucleus. What is a beta particle made from? A high energy electron. How does a beta particle get created? A neutron turns into a proton and creates a high energy electron. What is a gamma wave made from? It's a type of electromagnetic wave, or a magnetic field and electric field. Which type of radiation is most penetrating? That will be gamma. Which type is least penetrating? That will be alpha. Number 7, how does the path of an alpha, beta and gamma particle differ as they pass through an electric field? Well, alpha gets pulled to the negative, beta gets pulled to the positive, gamma will travel straight through. How does the path of an alpha, beta and gamma particle differ as they travel through a magnetic field? Well, alpha and beta will travel in different directions, but the gamma will travel straight through unaffected. Let's start looking at radioactive decays. First, we look at how to write the radioactive decay equation for an alpha emitting source. First, let's think about why radiation is given off. Unstable atoms will break down into smaller atoms to become more stable. Now, this throws off some particles that we detect as alpha or beta radiation. Now, since we've thrown off some particles, the number of protons or neutrons in the nucleus has had to change. And that means that the element that we're studying will also change. Let's look at how alpha radiation changes the nucleus. We'll use carbon-14 as our example, which has 6 protons and 8 neutrons. Now, if it gives off an alpha particle is made up of 2 protons and 2 neutrons. So we can write this as an atomic number of 2 and a mass number of 4. So to write our decay equation, we start with carbon-14 on the left-hand side. The arrow represents the fact that it's decaying, and then it forms something new. Now we also know that it gave off an alpha particle, so we can write this in. And with a simple bit of maths, we can work out what the new element will be. So we started with 14 on the top, and we lost 4 when the alpha particle was kicked out of the atom. So 14 minus 4 gives me 10. And we started with 6 on the bottom, and we kicked out 2 in the alpha particle. So 6 minus 2 is 4. So we can replace our numbers 10 and 4 into the equation. Now we can look up on a periodic table what element has 4 protons, and that is beryllium. So we can write the full equation. Carbon-14 6 forms beryllium 10 4 and gives off an alpha particle He 4 2. Let's look at another example. Let's imagine calcium-40 goes through an alpha decay. First, we can write calcium-40 with 20 protons and 20 neutrons. We know it's going to decay to form something new, and we know it gave off an alpha particle, so we can write that in. Now we can work out what the new numbers will be with a simple bit of maths. 40 minus 4 gives us 36 on the top, and 20 minus 2 gives us 18 on the bottom. So if we look up now what element 18 is in the periodic table, the thing with an atomic number of 18 is argon. So we can write in our new element as 3618 argon. Pause the video and complete task 1 to work out what new elements will be formed for each of the decays. Let's check our answers. The thorium 23290 will become radon 228 and 88. The uranium 238 with 92 as an atomic number will become thorium 90 with a mass number of 234. ZR 91 and 40 will become SR 87 and 38. And PT195 with 78 protons will become OS 76 with 191 as a mass number. Let's write the decay equations for beta emitting sources. Beta radiation is created when a neutron turns into a proton. This creates a high-speed electron. Now I can write beta radiation as a beta symbol or an E with a 0 as the mass number and a -1 as the atomic number, and we'll see why in a minute. So let's use carbon-14 as our example again, and this time we're going to put it through a beta decay. So we start off with what we are beginning with, carbon-14 on the left hand side, and we're going to form something new, and we know that we're giving off a beta particle. So we can write that in now as an electron with 0 as the mass number and -1 as the atomic number. Now we can work out what the new element will be by doing a simple bit of maths. 14 minus 0 is 14 on the top, and 6 minus -1 is going to be 6 plus 1, so that's going to be 7 on the bottom. Now this makes sense because if we think about what's happened in the nucleus of the atom, we started off with 6 protons and we've turned one of the neutrons into a proton, so that has increased in size from 6 to 7. And also the number of particles inside the nucleus hasn't really changed because a neutron was in the nucleus anyway and it's turned into a proton which is still in the nucleus. So we started with 14 and we ended with 14. So it makes sense that we've got 14 as our mass number and now we've increased the atomic number by 1. And now we can see why the beta particle has got this 0 and -1 as its atomic number. It's simply to make the numbers work because we're starting with 6 on the left and 7 on the right, and so the beta particle must be represented with an atomic number of -1 just to make that number work. Now if we want to look up what particle we've created, then the atomic number of 7 represents a nitrogen atom on the periodic table. So we can fill that in. Let's look at a second example. This time we'll use calcium 40. So we start by writing the element that we begin with on the left hand side. So that's calcium 40 with an atomic number of 20. We know it's going to form something new, and then we can write our beta particle being given off. And now we can work out what the new element will be by doing our maths. 40 minus 0 gives me 40. 20 minus -1 is 20 plus 1, so that's 21. Now if I look on the periodic table to find what element 21 is, I find out that it's scandium. gamma radiation doesn't change the nucleus, it just emits high energy gamma waves. So I don't need to worry about any changes to the nucleus, as in this case, as you can see, we're starting with carbon-14 with 6 protons, we end with carbon-14 with 6 protons, and we just give off our gamma radiation. Now pause the video and complete task 2. Let's check the answers. The first one, we have a mass number of 232 and an atomic number of 90. The mass number will stay the same, 232, but the atomic number will increase to 91. If we look up this element on the periodic table, it's Pa. The uranium 238 has an atomic number of 92, so this will increase to 93, but the mass number will stay at 238. So if you look up element 93, it's Np. In the third one, we've got Zr91 with 40 protons. The 40 will increase to 41, but the 91 will stay as the mass number. And if you look up what the element 41 is on the periodic table, we see it's Nb. And the fourth one, we've got platinum with 78 protons and 195 as a mass number. So the mass number stays the same, 195, but the atomic number goes from 78 to 79, which, if you look it up on the periodic table, is the element Au. An atom of potassium 40 emits a gamma ray. What will be left in the nucleus of the atom when the gamma wave is emitted? Well, since the gamma wave does not change the nucleus, we're still left with 19 protons and 21 neutrons, so it's still potassium 40. Let's start to look at the dangers of radiation. Radiation can knock electrons out of atoms. This process is called ionization. When this happens inside living cells, it can damage the cell or kill the cell. And if this cell multiplies, the damage can be passed on to new cells, which can cause cancers. Alpha radiation is the most ionizing type of radiation. It's because it's a large, slow-moving particle. Whereas gamma radiation is the least ionizing because it's a small wave that is very fast moving. Beta radiation is in between these two, so we can class it as middle ionizing. How could we work with radiation safely? A hazmat suit is a suit designed to reduce exposure of the body to contamination from radioactive sources. It's not actually designed to stop radiation getting to the person. It only prevents the radioactive source from getting on the person, on their skin or in their hair, or to stop them breathing in the radioactive source into their lungs. So it prevents the source from getting on the body, but it doesn't prevent the radiation from getting to the body. And it does this by covering the whole body and having an air filter. So when the air is breathed in by the person, it passes through a filter before it enters their lungs. Many jobs involving working with radiation ask their staff to wear badges which measure the dose of radiation they are exposed to. This type of badge is called a dosimeter. It measures the wearer's exposure to radiation in sieverts so that they can manage the risk by limiting the amount of time they spend around the radioactive sources. Any waste or rubbish that is potentially radioactive is classed as radioactive waste. Radioactive waste comes in 3 levels of danger. There's low-level waste, which is usually disposed of in regular waste bins. So this could include rubber gloves that have been used to handle a substance. Intermediate level waste. This may be encased in concrete or a special container. And this could include graphite from power stations and low-level radioactive sources. And then we have the high-level waste, Now this is more dangerous and has to be mixed with molten glass and cased in concrete. It's usually stored underground. And this might include uranium fuel rods from power stations. Let's pause the video and complete task 3. Let's check our answers to task 3. What does ionization mean? This is where electrons are knocked out of an atom and could cause damage to cells. Give 2 ways that a workforce can be protected from radiation. They could wear a hazmat suit or be supplied protective clothing, or wear a dosimeter badge or limit the exposure they have to the radiation. What is the purpose of a hazmat suit? Is to prevent contamination of a radioactive source from getting on a person's skin, hair, or breathing in the material into the body. What is the unit that a dosimeter will measure the radiation? It's sieverts or millisieverts. What are the 3 types of radioactive waste? And give an example of each. So we have high-level waste, which could be nuclear fuel rods, intermediate level waste, which is like the graphite from power stations or low-level radioactive sources. And there's low-level waste, which is disposable gloves or clothing that was worn around radioactive material.